So, good evening to everyone. Today we are discussing about boolean algebra of stld syllabus. I am Lakshmi Srivastava from ECA. Now we can start our topic. Title you can see that this is introduction of boolean algebra. Written by this my name Lakshmi Srivastava. Okay, table of contents. We can see in this introduction. We can discuss in this video. This all these topics. Introduction to Boolean algebra, basic postulates, theorems, Boolean function, truth table. These all topics will cover in this video, in this seminar video. We can now learn about Boolean algebra concept. What first we want to know what is Boolean algebra? Definition: a branch of algebra values and variables, true values, true or false, denoted by one. True values are denoted by 1 and false statements are denoted by 0. This is a mathematical system of analysis, simplified logic circuit and developed geological mid-19th century. This is developed by George Boolean in 19th century. Key concept we can learn about and or and not. Basic postulates. Postulates we can see about Boolean algebra is binary variables can only have two 0 and 1 represent only 0 and 1. A logical multiplication input 1 and inputs are 1. Or you can see the operations of R is A plus B is the logical condition is 1. Now we can see basic theorems and on operator. We have so many laws. We have cumulative law, associative law, distributive law, identity law, idempotent law, commutative law, and absorption law. This Boolean algebra is very important to our coming exams. Number of times asked. This is very important. Basic theorems. We have so many of theorems. These and these commutative law, associative law, distributive law, and sorry for disturbance. We have as seen in this. We have so many operations with this we can do. Finally, we can see that Boolean function truth table. A Boolean function is an expression for construction of binary variables and three basic Boolean operations. In this, we have see inputs are 0 0 0. We get 0. This is output. So if two ones are there, we can add it. In this table, we clearly see the operations of f of a comma b equal to a plus b. Simply, we can calculate with this method. Introduction to logic gates. Logic gates it is an important topic in our concept. Boolean algebra. We can see logic gates are electronic circuits that implement basic Boolean operators. Logic this can be the logic gates are electronic circuit to implement basic Boolean operations. We have seen this operation. These operations are all done with logic gates only. Simply, simply we can do with the logic gates. They are fundamental building blocks of a digital system as symbol. Sorry for the it's, and symbol we can represent and by the symbol. You can all see this is symbol. Now this is the truth table of this. Inputs are A and B, 0 0 equal to 1. 0 1 comes to 0, 0 comes to 1, and 1 comes to 1. So the output is I 1 only 4. Okay, you can say not get. Not get is like the complement we can also call as a symbol. So we have this bubble. This bubble is very important. This bubble is very important. Again, this bubble only represents this symbol is not gate. Universal gates, NAND gate and NOR gate. These are very important gates. We can use this gates in so much of ways and so many ways. These are called universal gates because these gates are very very important. You can take out two table in next. Okay, we can discuss about this is an important theorem, De Morgan's theorem. We have so many important topics in this Boolean algebra. Theorem 1, theorem A not B equal to B, theorem 2, A plus B equal to A dot, this is by mistake, this was code significance. This provides a method convert an AND operations to OR and vice versa. It can do reverse also. Taking the line and changing signs. Simplification of expression. Why simply? This is this is why simplify. This can know the what is the importance and where we can use in our day to day life. Using Boolean algebra K-map. This K-map concept also very very important. We can see in next. Introduction of Introduction to K-map. K-map is a graphical method simplifies the Boolean expressions. It is alternative using Boolean theorem and practical effect of function and variable principle. It arranges the truth table values in a way allows easy identification and adjustment terms that can be combined. Now, let's see. Came up are three variables for three variables. You can see came up for three variables. Section 2 and 4 grouping adjustment horizontal or vertical and grabbing can be grouped for up to comma 4 comma 8 etc. Simplification. Simplification we can see as it follows simplification. K-map example as a K-map example. This application is very important. It is used in computer architecture and central processing units, programming, conditional system, if and else loops, and search engines combined to keyword and are not. There's so many uses of this algebra, Boolean algebra. This is summary. Boolean algebra is foundation of modern digital electronics. It uses a binary system, 0 and 3 primary operations, and or not. Logical gates are to physically realize these operations are De Morgan's theorem and using K-maps and powerful tools are simplifying logic experiments and leading more sufficient circuit designs. This Boolean algebra uses the complex circuit we design is converts into simpler form and K-maps will draw the graphical representation of the code and it also physically represent we can see in the systems that how it is processing the code and output will be verified within this K-maps and De Morgan's theorem. We can efficiently do the work easily and fastly. This we can see this video is cutted, so this is recording. K-map example problem simplifying a found a sum of n terms. Sum of a m term is 0 to 4 4 5. 0 to 4 places. Step 1, create a game of places one cell corresponding cells and step 2, grouping and adjustments once. Write the simplified expression where the group are equal to B and C. We can, I will say one example. This schema is run like this. B, C, D, C. Okay, we can write the numbers. This is 0, 1, 2. This is 3. This is the process we can write K maps, numbers doubling. This 4, 5, 6. We can say we will 4, 5 and we will skip for number and write here 6 and again we come back and here we can write 7. Now, for example, we write uh, some example 3, 7, 2, 6. Now, write at this number space, write 1 in this K map. We can say 3, 7, 2, 6. Now we can say it will form an quadrant, means it will form 4. We have 4 respectively side by side. We can join it. We can say it is a quadrant. If we have only 3, we can join like this, like pairs, and this like pairs. We can join 3. 2 means if we can pair like this. Now now we have 0, 0, 1, 0, 1. Maybe we can say, as I said that we can form quadrant. We can form quadrant. Now we can have P, P is 0, 0, 0, 1, 1, 1, 0. This is 0 and 1. We have with respect to this paper of this one. Yes, we can say 1, 1, 1. So now we can say this one. So we have B, C, divided as B, C, and um, plus B plus B dash, and we have 8 and plus A plus A. So now like this we can do K-map. So this we can say we can learn about the modern serum and K-map powerful tools. We can already discuss about this. These are very powerful tools and we physical variation and operations about today. Thank you guys.